before we look at the next example, I want to go over a type of question we did before. Say a plus b times c minus d. And we know this is a binomial, two terms times a binomial, two terms. We can either use FOIL or we can use distributive principle. So when we use distributive principle, we have to distribute a and b separately to c minus d. So first we can temporarily forget about plus b. We just distribute a to both of them. So we're going to have a times c, and then we have a negative a times d. And then after we're done distributing a, we're going to distribute, let's put plus b back. We're going to distribute b. When we distribute b, we don't have to, you can pretend that you don't have a there. So we're doing negative b times c. So that gives us positive bc because it's positive b here. And positive b times negative d, we get negative bd. And for addition and subtraction, we look for like terms to combine, but we don't have any like terms. We can stop here. Okay, so this is how we did this problem before. Now, for radicals, we have similar questions. So we can look at the example. Square root of 3 plus 4 times square root of 3 minus 5. And this is very similar to a plus b times c minus d, and its multiplication between them, and something plus something times something minus something. Because we cannot add 4 to square root of 3, they're not like terms. One has radical, one doesn't. The same for radical 3 minus 5, just like we cannot add a and b, c and c minus d. But we can multiply them by distributive principle, or you can do FOIL. And so we can do it similarly. So first we forget about this plus 4 here. So we're just going to multiply square root of 3 and square times square root of 3 minus 5. So we're going to distribute square root of 3 to both of them. And let's slow down to write down square root of 3 times square root of 3. And then minus square root of 3 times 5. We like to put in numbers in front of the radical. So I'm going to put 5 times square root of 3. And when we done distributing square root of 3, we can put that plus 4 back. Now we're going to distribute a 4 to both of them. So that gives us plus 4 times square root of 3 and plus 4 times negative 5. We can go ahead and write down the minus 20, positive 4 times negative 5. So it's very similar to the problem we did before, but we have radicals in here. Now let's multiply square root of 3 times square root of 3. In the previous video, we already talked about how to multiply them. So we can, because it's multiplication, we can multiply the numbers, the radicand, with the radical sign. And then minus, we can slow down a little bit to simplify that part first. So if you can see square root of 3 times square root of 3, which is equal to 3, you can skip this step right here. You may skip this step. But if you can multiply then square root of 3 times 3. 2 copies of 3, they can come out to get a single 3, and nothing will remain under the radical sign. So it's actually, you have a 1 left, but square root of 1 is also 1. You don't really have to put anything. Or you can just do square root of 9 is equal to 3. Now, but for the radicals, again, let me just go ahead and copy this and combine them later. So the next step, we combine like terms. Apparently, these two are like terms because they both have square root of 3. Square root of 3 matches with square root of 3. And these two numbers, 3 and minus 20, they're numbers. We can also combine them. So we can do 3 minus 20, that's negative 17. Negative 5 radical 3 plus 4 radical 3. For addition subtraction, we keep the radical and we add or subtract the numbers in front of them. So we're just adding negative 5 plus 4. So we're doing negative 5 plus 4. That gives us a negative 1. times square root of 3. And that 1 can be omitted. So if you want, you can omit that 1 there. So the answer will be negative 17 minus square root of 3. Again, this is like doing negative 5x plus 4x, which give us negative 1x. And the x is square root of 3 here. And these two cannot be subtracted because they're not like terms anymore. One is a radical, the other is not. So that's how we do example 3. Now next, we're going to talk about division. So far we have talked about different types of multiplication questions. So now, what if we have division? So for division questions, notice that division you will have fractions, because divide by something is like fractions. You may have denominator. So we have to apply these two rules. And let's look at negative 5 divided by square root of 3 minus 2. Now this is a problem which needs a completely new technique. So this technique can also be applied to other questions in like high level math. And so let's see. The idea is, first of all, because of these two rules, no fraction appears with the radical sign. Well, the radical sign is right here. This is the only radical sign we have, square root of 3. The number with the radical sign is 3. It's a whole number. It's not a fraction. So we don't have to worry about rule number 2. But rule number 3 says no radical appears in the denominator. This is a fraction we have for division. And the denominator is square root of 3 minus 2. Apparently it has a radical sign. That's not allowed in the simplest form. You may have radicals in the numerator, but not in the denominator. So how do we get rid of it? Previously we discussed this is something different from what we had before. For example, if I don't have this minus 2 here, or I have a times 2. So compare this question, this is example 5 here. Compare this question to a problem we did before. I'm going to write down the problem here. What if I change the bottom to square root of 3 times 2 instead of minus 2? And we know that to get rid of square root of 3, we can multiply another copy of it, because times another copy of square root of 3 times another copy of square root of 3. And the square root of 3 times square root of 3, that gives us 3, because that gives us square root of 9, which is 3. So that will help us to get rid of that. So 3 times 2 would be 6. And negative 5 times square root of 3 would just be negative 5 times square root of 3. So this will get rid of the radical in the denominator, but you are allowed to have radical in the numerator. The problem here we have is it's a minus. And if we multiply another copy of square root of 3, notice that you have to multiply the entire bottom by square root of 3, not just the first term. Over here, because it's multiplication, when you multiply square root of 3 to the bottom, and you just only need to multiply the first two. You don't need to distribute the square root of 3 to that, because it's not a subtraction here, it's multiplication. You multiply the first two numbers and then you multiply the third number. But if you have a minus here, unfortunately it doesn't work. When you multiply square root of 3, you say, let's do that, check, see if it works. If I multiply the bottom by square root of 3 and also multiply the top by square root of 3, and notice that we have to distribute this to both of them. When you distribute the square root of 3 to the first one, you get square root of 3 times square root of 3. That gives you a 3. But square root of 3 times negative 2, that gives you a 2 times square root of 3, because this 2 is not with the radical sign, but this 3 is with the radical sign. You cannot really multiply them. You just have to keep them there. And after we multiply square root of 3, we did not get rid of square root of 3. We did get rid of this square root of 3. But we come up with another square root of 3. That's not what we want. We want to get rid of square root of 3 completely. So that's why this way doesn't work. And that's a technique that we have to remember. So if multiplying square root of 3 doesn't work, what should we do? We are actually going to multiply square root of 3 So this is what we're going to multiply. You have to memorize that, this technique. We're going to multiply square root of 3 plus 2. And so pretty much it's almost the same as the bottom, except we're changing this minus to a plus. And also multiply the same thing on the top. Whatever we multiply on the bottom, we must multiply the same thing on the top to keep the equivalent fraction. Okay, so why would this work? Notice on the bottom, it's similar to example 3. You do FOIL or just multiply. So on the bottom, square root of 3 times square root of 3. That gives us 3. So let me put it down the answer here. So on the bottom, multiply square root of 3 and square root of 3. As in this example, square root of 3 times square root of 3, that gives us 3. And then we multiply square root of 3 times positive 2. That gives us a 2 square root of 2, 2 square root of 3. And then we multiply negative 2 times square root of 3. That gives us a negative 2 square root of 3. And negative 2 times positive 2. That gives us a minus 4. And notice that these two terms can be cancelled because one of them is positive 2 times square root of 3. The other is negative 2 times square root of 3. They can be cancelled. Because 2 minus 2 is 0. And we're only going to be left with the 3 minus 4. They're both whole numbers. When you subtract them, you will get a whole number, negative 1. So that's how we got rid of the radical sign successfully. So what do we do have a name for this. We call this a conjugate. So if there is a plus sign or minus sign in the denominator, and how do you get rid of that radical sign? We must multiply its conjugate. What is a conjugate? You copy everything except changing the sign. If it's minus, you change it to plus. If it's plus, you change it to minus. That's called a conjugate. So now we can work out the top. For the top, we are distributing negative 5 to both of them. So we have negative 5 times square root of 3. We have negative 5 times positive 2, which is negative 10. And now we simplify the bottom. As we said, this positive 2 square root of 3 minus 2 square root of 3, they're cancelled. We have a 3 minus 4. That gives us a negative 1. And the top, we copy the top. Because this can be distributed further, so we're going to divide each top by the bottom, negative 1. Negative 5 divided by negative 1, it's positive 5 square root of 3. Negative 10 divided by negative 1, that gives us a positive 10. So this will be our final answer. In this case, we actually got rid of the bottom because the bottom is 1, or negative 1, but normally you will have a number on the bottom, so you may have a fraction and the whole number on the bottom. So let's look at another example using this idea. Example 6. So we have maybe 5 over square root of 3 plus square root of 7. So again, if there's a plus or minus sign in the denominator, you have to multiply its conjugate. So remember, multiply the conjugate to get rid of the radical sign. Okay, so look at the bottom. The conjugate will be changing the sign. So we have a plus. That means we're going to change the plus sign to a minus sign. But you have to copy in exactly the same thing. Square root of 3 and square root of 3, square root of 7, square root of 7. And we're going to do the same thing on the multiply the same thing on the top. Exactly the same thing. Compared to the previous example, only one of the terms has a radical sign. That's why only the other is 2. So we're going to have copy them exactly, just changing the sign. But in this case, we have both 2 radicals, and again, you copy them. So next, we're going to simplify them by doing FOIL or distribute. Now, square root of 3 times square root of 3, and that's 3. And square root of 3 times negative square root of 7, that gives us a negative square root of 21. And then we distribute this one. Square root of 7 times square root of 3, that gives us a positive square root of 21. And then square root of 7 times negative square root of 7, that gives us a minus 7. Because 7 times 7 is 49, square root 49 is 7, and then distribute the top.